Hello everyone, my name is Glenn and welcome to the part 2 of our discussion of organizing numerical data. We are currently on the steps of constructing a frequency distribution table. Now these steps that I'll be presenting is just an ideal type of constructing a frequency distribution table. So the first one is to take the range wherein you take the difference of the highest score and the lowest score from the observations or the raw data. The second step is to determine the class interval. Normally, most of the books would just suggest that you choose from 15 or 5 to 15 groups. But in our ideal steps in constructing an FDT, we have here a formula where n is your class interval and big N is the number of observation or your number of raw data. Step 3 is to compute for the class size. We call this the members per group or members per class interval. Formula used is the range divided by the class interval. Step 4 is to set up your class interval, or you set up the frequency distribution table starting with the class interval, where the lower limit of the first group is the lowest score and the upper limit has this formula: lower limit plus your class size minus 1. Sometimes this doesn't work if we are dealing with decimal numbers, but if it's a whole number, then normally we subtract 1. The last group should contain the highest score. Then lastly, complete your frequency distribution table of the required details. So normally we have the frequency, the class mark, the cumulative frequency, and relative frequency. Okay, so before we proceed in applying these steps, let me just go back to my previous discussion where we talked about frequency distribution table, but this time I'll be showing you shortcut or the use of a function in Microsoft Excel. So considering that you are given a raw data wherein this is not ordered, they are not arranged in highest or descending or ascending order. So let me just delete this frequency first and let me show you a shortcut. So instead of counting or manually looking for the members for each group, we have a formula called COUNTIFS. Alright, so we have criteria range 1 and then the criteria. So in our first interval, we are trying to look for the number or the frequency from the class boundary 20 to less than 30. So that using our formula COUNTIFS, we just input our criteria range 1. This is our raw data or the set of our raw data. And for our criteria 1, we choose now greater than 20 or greater than 19. So we are starting from greater than 19, meaning we would like to have values greater than 19, but we have a boundary that should be up to less than 30. So we'll have to fill in criteria range 2, and we also take the same raw data or the same set of data. This time we place our criteria range 2 that our boundary is only from 20 up to less than 30. So that's less than 30. Then press OK. So it automatically counts all values on our raw data having the values from 20 to less than 30. So there are a total of 6. Okay, and then we can copy this formula, but before we copy it, we make sure to lock down our set of observation by putting a $ on the letters and numbers of our criteria range. Remember that we have two criteria range 1 and criteria range 2. Then press enter. Now we can drag the formula. For our second group, we have to update our range. It should be greater than 29 and less than 40. So that's 7. Double check. That's greater than 29, less than 40. Third group, this should be greater than 39 and less than 50. Fourth group, this should be greater than 49 but less than 60. Fifth group, this should be greater than 59 but less than 70. Then the last group, this should be greater than 69. Sorry, that's 69 but less than 80. Okay, so as you notice, our total of 50 row data is correct. Okay. Now the next thing that I would like to discuss about is the relative frequency. So relative frequency is pretty much the quotient of the score of the group divided by the total number of observations. So this time, for our first group relative frequency under city column, that's 6 divided by 50. So on our Excel, that's press equal sign, choose the cell where 6 is located, then divided by 50. That's 0.12. You can copy the formula and everything will have its correct relative frequency. Similarly for this column of suburban, so our first row, that's 5 divided by 50, it should be 0.10. So checking the formula, it's AJ 5, so row AJ, column 5 divided by 50, and that's correct. And you can drag all the formula so that if we look at the sum, it should be equivalent to 1. There you go. So this is the relative frequency. Another concept would be the cumulative relative frequency. This time, we'll simply get the sum of the cumulative frequencies or cumulative relative frequency. So for the first row, this would be equals to the first relative frequency. In percentage form, that would be 12%. Now, I'll change this to percentage as well, so we could actually view this in percentage form. Change everything to percentage, so that this cell here would be the sum of this first two. That's, oh sorry, it should be the sum. There you go, that's 26%. Then for the third column, the less than cumulative frequency, for the third column, add all these three cells or relative frequency. Similarly for the fourth column, we'll take the sum of the first 4. The fifth column, we'll take the sum of the first 5. And the last column, it should be the same as the 100% total of the relative frequency. We simply sum it up. There you go. So similarly for this column of suburban meal, we do the same thing. copy the first, then add, keep on adding. But this time, let me try to show you another way of okay. So I'll choose this cell where that's BF5, column BF, row 5, plus this cell. It's the same as adding this, but this time I add 10% located on this cell and 34% located in this cell. So that's 44. This time around, I can drag the formula because it follows adding these two. Okay, so what's the use of cumulative relative frequency? By the way, you can also call this as the cumulative percentage distribution. So for example, a question here, what percentage of meal is less than $50? So we simply look for less than $50. Okay, so all meals here are less than $50. So for city restaurants, that would be 64%. And for suburban restaurants, that would be 78%. So in our decision making, or in our conclusion, we can say that there are more $50 or there are more less than $50 meals on a suburban restaurants than city restaurants. Another question here, what percentage of meal is $50 or more? This time around, we don't have the answer on our table because we need to add what we call the greater than cumulative relative frequency. So this should be greater than cumulative relative frequency. So that will start at the bottom. That will be equals the relative frequency. And then we add this two to get this cell. So equals, you have 6% plus 12%, that would be 18%. Third column, sum the first three, or take the sum of the first three, that will be 36. Next column going up, add the first 4. Then this one, add the first 5. Then this one, add the whole or everything of the relative frequency. The sum should be 100%. So we do the same for suburban. We'll eventually follow the same procedure. We paste it on the wrong cell. Okay. There you go. So we are looking for meals which are $50 or more. So this area. So all of these meals are $50 or more. So that for city, we should look on the greater than cumulative relative frequency. So that should be $50 or more. It should be 36%. And for suburban restaurants, this should be 22%. It's 22%. So notice the sum of these two should be 100%, and the sum of these two should be 100% as well. So there you go. Talk about the cumulative relative frequency, or if they are in percentage form, we normally call it the cumulative percentage distribution. Then this is also the relative frequency, and a shortcut using the Microsoft Excel function COUNTIFS on taking the frequency of a raw data. Now let's move on to utilizing the steps that I gave, the ideal steps in constructing an FDT. So say for example, this is your only row data. You have collected it and you are tasked to present it in a tabular form. Normally, it should be presented in an FDT form. So we follow the steps, find the range, get the difference between the high score and the lowest score. So it will be a hard or a big problem if we have problem in identifying the highest score in this row data. So in Excel, we actually have the formula called maximum. We look for max, so that's equals max, and it will actually locate the highest number. So this returns the largest value in a set of values. So press OK, and there you go, the highest score is identified as 79. And then the lowest score, we have the minimum function. It will identify the lowest value in the set of numbers, or the smallest number in the set of values. So there you go, the lowest score is 21. The difference of this, so 79 minus 21, that's 58. So I'm done with step 1. Step 2 is to determine the class interval small n by using the formula small n is equal to the square root of big N. Your big N here is the number of observation. So the total number of observation is 50. Now we take the square root of 50. So in Excel we have the formula square root, that's SQRT, and then we choose 50, or the cell where the number of observation is located. Press OK. So the square root of 50 is 7.07. I'm done with step 2. Step 3, compute for the class size I. It's simply the quotient of R and small n. So this is equals, this is capital R divided by small n. That's 8.2. Now in the ideal steps in constructing an FDT, we normally round this to the nearest odd number. So that would be 9, meaning there will be 9 members per group. So that our group is around 7. So this is 1, 2, let me put some numbers so that we can identify that there are around 7 groups. And in these groups, there are 9 members per group. So to set up our class interval, we start with the class interval. We start with the smallest number, or the lowest score, that's 21. So that's our first row. And then we now add 9 to get the lower limit of our second row. So this is equals 21 plus 9. That would be the lower limit of our second row. We drag the formula, it will eventually do the same thing. Okay. Now to take the upper limit of the first column, just subtract 1 from the lower limit of the second row. Again, to take the upper limit of the first column, just simply subtract 1 from the lower limit of the second row. So that would be 29. Or we can follow our procedure. In taking the upper limit, we simply get the lower limit plus our class size minus 1. So we have here 21 plus our class size, which is 9. That would be 30 minus 1 is 29. Okay. Then to complete the rest of the upper limit, simply add 9 from the upper limit preceding the row you are working on. So this is equals the upper limit on the upper row plus your should be 9. Again, that's L12. Oh, it shouldn't be L, it's N. Let me redo that. That's equals 29 plus 9. That's 38. So we have 29, 30, 38, 39. So that's correct. And drag the formula, and you are now complete with your class interval. Now we take the frequency. So in our frequency, we will now refer everything to our class interval. Okay, so this might be a little different from the steps that I made here because my reference is class boundary. For this example, my reference would be class interval. So if I take the frequency of this first group from 21 to 29, those are exact values. I'll be using the function COUNTIFS, and my criteria range would be this set of data. And my first criteria, I'll be needing to input all values from 21, so that should be greater than 20. Then criteria range 2, and my criteria 2 would be less than 30. So that would be less than 30. Okay, so meaning there are 6 frequency from the class interval 21 to 30. And looking at my formula, that's greater than 20 but less than 30. So that's correct. The boundary is from 21 to 29, or the boundary is greater than 20 but less than 30. Now I can copy this formula, but let me lock up the range first by putting $sign on the letters and on the numbers, and press enter. Drag the formula. Now update every row. So this should be from 29 to less than 39. Again, check 29, greater than 29 but less than 39. And this should be greater than 38 but less than 48. And this one should be greater than 47 but less than 57. So greater than 47 but less than 57. And this row here should be greater than 56 but less than 66. 56 and 66. And this row here should be greater than 65 but less than 75. So 65 and 75. The last one should be greater than 74 but less than 84. Greater than 74 but less than 74, or 84. You might be asking, why is there an 83 on our class interval and our highest score is only 79? Well, that's okay. This is simply an ideal type of presenting a data in a tabular form, as long as we follow, or we started with the first or the smallest score, and as long as the high score it is included on the last or the highest class interval, that would be okay. Now, what's the difference between class interval and class boundary? For class interval, for the first row, to take the lower limit of the class boundary for the first row, we simply take the lower limit of the class interval, but we subtract 0.5, and we do the same for the rest. Okay, so notice now for the upper limit of the class boundary, we take the upper limit of the class interval of that row, and then we add 0.5. We do the same. So for class boundary, notice that the upper limit of the first row should be equal to the lower limit of the second row. Upper limit, lower limit. Upper limit of the first row, lower limit of the next row. So the difference, they have the exact value for these areas. For class interval, there shouldn't be an exact values for this. There you go. So for the class mark, we can either add the lower and upper limit of the class boundary, then divide it by 2, or the class interval, add the lower limit and the upper limit, divided by 2. The result will simply be the same. So if I have this 21 plus 29, and then enclose it in a parenthesis, then divide it by 2, that's /2, press enter, and you have 25. Copy the formula, that's 34. If you apply it here, this plus the upper limit, divide by 2, press enter, the result is the same. Okay. Now for cumulative frequency, less than cumulative frequency, this is talking about the frequency. So we simply add the frequencies together, but this time in cumulative. So we have the 6 for the first row. For the second row, this 6 plus this 6. For the third row, this 12 plus this 16. So I can actually drag the formula down, and there you go. You'll notice that this 50 should be equal to the sum of the frequency. So if I take the sum of the frequency, I add this all, it should be 50. So that's correct. Now relative frequency, simply take the quotient of the frequency and the total row data. So this is equals 6 divided by 50, that's 0.12. Well, normally in percentage that would be 12%. So that the sum should be 100%. Okay. Then relative frequency, or less than, it should be less than cumulative relative frequency. So do the same with this column. Okay, then drag the formula. So there you go. These are the ideal columns for constructing a frequency distribution table. So again, going back to the steps, first is to find the range. Second, to find the class interval small n. Then third, to take or compute for the class size I. And then lastly, you set up your frequency distribution table based on the details that is expected to come out, or the details that are needed on any problem set you are working with. So that's it. Thank you for watching.